Okay, so 6.2 is another procedure for solving quadratic equations, and that's what we're going to focus on for this unit of solving for the x value that will give you a specific y. Last unit we solved quadratic equations when we wanted to find out the values of x to make the equation equal to 0. So that meant that we were finding the x-intercepts, which remember are our roots and are also our zeros. So far we solved quadratics by factoring and setting the brackets equal to 0 to find the roots. We're going to continue that today, but it may not equal 0, so we're going to continue on with that. So if we look down at example 1 and you're asked to solve a factored form equation for when it equals 0, we're asking what would make one or both of the brackets equal to 0. So we need to set each bracket equal to 0. So x plus 3 would equal 0 if x was negative 3, and x minus 4 would equal 0 if x was equal to 4. Okay, so that meant that we had two possible values, that x would be a negative 3 or a positive 4 for the equation to equal 0. So for our y value to equal 0. Either value of x would make 0 times another bracket, so therefore we would equal 0. Okay, so that's the key thing, that we could have two x values. And if you think back to your parabolas, we could have two x-intercepts. So remember that it's also possible to have one of our brackets be a single variable. So in example 2, x times x plus 5 in brackets, what would make those values equal 0? So we have to remember that when we have just a single x, that is still one of our factors. So if x has a value of 0, we would have 0 times the bracket. The other option is that x plus 5 can equal 0, so therefore x could be a negative 5. So again, we still have two x values that would make the entire equation equal 0. So now what I want you to do is take a quadratic that's in standard form, x squared minus 17x plus 30, and make that equal 0. So what x values will make the entire equation equal 0? So we're looking for our roots. So factor this equation, set each bracket equal to 0, and find those values. So pause the video while you factor this and solve for the x values. So remember, when you were factoring, you were saying what multiplied to a positive 30 and added to negative 17. Your options would be negative 15 and negative 2. So one bracket is x minus 15, the other bracket is x minus 2. Solving each bracket, we can find out our two possible x values, or our roots, and that would give us a positive 15 or a positive 2. Okay, so let's look on. What happens when the quadratic doesn't equal 0 to start? Okay, so example 4, negative 10x squared plus 32x plus 6. The first step when we want to solve our roots is that we want our entire equation to equal 0. You cannot factor unless it equals 0. So we move the 6 to the other side by subtracting it. So we have negative 10x squared plus 32x minus 6. Now we need to factor. Always look for your GCF first and then factor. So if we look at all of this, we can see that all the numbers are even, and we want our x squared term to be positive. So take out a negative number so that we're left with a positive x squared inside our bracket, and then I want you to factor and solve. So pause the video and press play when you're ready to continue. Okay, so when you factored out a negative 2, you were left with 5x squared from dividing negative 10 by negative 2. You were left with minus 16x in the middle from 32x divided by negative 2. And the negative 6 divided by negative 2 left you with plus 3 as your last term. So remember, you're thinking first times last adds to middle. So what multiplies to 15 and adds to negative 16? a -1, and a -15. So if you need to do the decomposition and factoring by grouping, your middle term of minus 16x became minus 15x and minus 1x in either order. You then factor out what's common, so you get 5x, you're left with x minus 3, and you can only take out a -1, and you're left with x minus 3. -2 outside the bracket is not one of your factors. There's no x term. So you're just going to take each bracket and set equal to 0 and solve. So what would make 5x minus 1 equal 0? And what would make x minus 3 equal 0? So we can just add 3 to the right one and we get x equals 3. If we add 1, we're still left with 5x equals 1. So x can either be a 1/5, or we can simplify that to decimal form as 0.2. All right, so the last example, example 5, okay, you want to simplify this question. So the length of a rectangle plot of land is 7 meters greater than its width. Okay, so again, the length is 7 greater than its width. Okay, so if we say x is the width, our length will be x plus 7. The diagonal is 8 meters greater than the width, so our diagonal is x plus 8. We want to know what our dimensions are. If you draw a sketch and visualize this, you'll see a right triangle. All right, so you see that it is a Pythagorean theorem, so we can treat our width and our length as our two lengths for a squared plus b squared will equal c squared. So again, you want to make sure that you see the connections. So once you have your brackets to be squared, you're going to expand them. So x squared plus, remember when you're saying x plus 7 times x plus 7, square the first, square the last, double the product. And same thing on the other side of the equal sign. Square the first, square the last, double the product. Now, in order to solve this equation, we need to get all the variables on one side, all right, or we need to make it equal 0. So first step, let's collect all our like terms. So we're going to move everything that's on the right side to the left side. So we subtract x squared, we subtract 16, and we subtract 64. Collecting like terms, we now have x squared minus 2x minus 15 equals 0. Because this is a quadratic, you cannot just isolate x. We need to use a method. So we're going to use factoring. So go ahead, factor this, and find out what your possible dimensions are, and press play when you're ready to check. Okay, so remember, we're thinking what multiplied to -15 and added to -2, we have a -5 and a +3. That, remember, middle sign goes to the bigger number. So we have x minus 5 can equal 0, or x plus 3 can equal 0. So solving these two brackets, x can be 5 or it can be -3. But is it possible to have a width of a negative measurement? No. So we know that 5 is our only logical value for a width. So therefore the dimensions will be 5, and then the length was 7 more than that, so 12. So the rectangular plot of land is 5 meters by 12 meters. Okay? All right, so you're having your quiz on 6.1, completing the square, and then we're going to be working through some practice problems in class when you're done. 1 to 6 letters, A and C, in class. So look over a couple of those problems now. They get harder in difficulty from questions 1 to 6, and we'll continue to work on those in class after your quiz on 6.1, and we'll spend a second day tomorrow on these, and we're going to focus on the word problems. So we will have some more practice problems in another video.